Today, we're going to uncover a hidden force that pushes complex systems, from global supply chains to entire economies, to methodically tear down the very thing they need to survive. For decades, this has been the holy grail of modern management, right? The relentless, unending pursuit of efficiency. The dream is a system that's perfectly tuned, giving us exactly what we need, right when we need it, with absolutely zero waste. It's a process of perfection. But then, the real world hits back. A pandemic, a financial crisis, a natural disaster. And that perfectly tuned system, it doesn't just bend, it shatters. Seemingly overnight, the shelves are empty, the factories are silent, and the whole network just collapses. Now here's the thing, this isn't an accident. This fragility isn't a flaw in the system, it is the logical, totally inevitable result of the system doing exactly what it was designed to do. There's a hidden structure at work here, pushing rational people to create a completely irrational outcome. To really see this structure, let's picture something simple. Imagine a series of really big, interconnected water tanks. Now, if a sudden surge of water hits one end, what happens? The tanks just absorb it. The shock spreads out across all that reserved water, and the system stays stable. Easy enough? So what does this look like in our modern systems? Well, it all starts with this relentless drive to optimize. The system basically declares a war on waste. The system even defines its enemy, using the language of lean manufacturing. It identifies these 7 wastes. But one of them is seen as the root of all evil: inventory. Having extra materials, extra products, anything just sitting in reserve is seen as a cost, a liability that has to be eliminated. So, the logical solution? Only get what you need exactly when you need it. This is the core idea of just-in-time manufacturing. If you get rid of your stockpiles, you cut costs and you boost efficiency. From a local perspective, it makes perfect sense. Now let's go back to our water tanks. All that wasteful water sitting around, it's gone. The big tanks are drained and they're replaced with a network of narrow, high-speed pipes. The water flows way faster now, way more efficiently, with nothing held back. And the consequence of all this newfound efficiency is, well, extreme brittleness. A tiny delay, one single blocked pipe, and the entire system grinds to a halt. We all saw this during the pandemic, right? Just-in-time systems had no stockpiles, so when disruptions hit, they couldn't cope. Widespread shortages were the inevitable result. So we've got a real puzzle here. How does removing something that you call waste actually make a system weaker? What was that waste really doing behind the scenes? Okay, think about any company. On one side, you have its total resources, everything it's got. On the other, you have the payments it has to make just to keep the lights on. In a perfectly efficient world, those two things would be exactly the same. But they're almost never equal. That gap between what you have and what you absolutely need to spend, that surplus isn't just fat. It's a hidden functional component. It's a buffer. And that buffer, that's the whole ballgame. It's what gives a system the ability to adapt. It's the resources you have on hand to deal with the unexpected, to try out new ideas, to absorb a sudden shock without just falling to pieces. It is the very source of resilience. And here is the core mind-bending paradox. The system's own logic looks at this vital, adaptive capacity, this crucial shock absorber, and sees a flaw. It gives it a name: inventory, excess capacity, waste, and then it works tirelessly to eliminate it. Now, this isn't just a series of bad decisions. It's a structural trap. It's a mechanism that forces the system to consume its own resilience, whether it wants to or not. The trap is set by how everyone in the system behaves. See, they aren't optimizing for the good of the whole system. They're satisficing, a great word. That just means they're making decisions that are rational and good enough from their own little corner of the world. And these good enough local decisions create an absolutely inescapable feedback loop. So, Firm A cuts its inventory, its slack, to lower its costs. That's a rational move. But now firms B, C, and D have to do the same thing just to compete. Suddenly, the whole system's ability to absorb a shock has dropped. This new, more fragile state becomes the new normal. And the cycle just starts all over again. We can finally put a name to this thing. That buffer, the difference between total resources and what's absolutely necessary, it's called organizational slack. It is the system's shock absorber, and this feedback loop is structurally designed to devour it. And back in our physical world, the transformation is now complete, and it is irreversible. That flexible network of pipes has been replaced by a single, permanent concrete channel. It is perfectly optimized for one single purpose: moving a predictable amount of water as fast as possible. There are no other options. The structure is locked in. So this brings us to the final act. We have this brittle, locked-in system, and it's facing a complex and completely unpredictable world. Think about it. An optimized system is, by its very definition, a system that has systematically removed its ability to adapt. It is tuned perfectly for one set of conditions, which makes it totally unprepared for a real surprise. And when that surprise inevitably shows up, some disturbance the system was never designed for, it decompensates. That's the technical term for when its ability to cope is just gone. The buffer has been completely used up. And because efficiency created all these tight connections, a single failure somewhere doesn't stay local anymore. It becomes a system-wide risk. The shock isn't absorbed, it's amplified, ripping through the whole rigid structure in a cascade of failures. But from the perspective of its own internal logic, the system never failed, not once. It was succeeding perfectly. It followed its own rules of optimization all the way to their logical conclusion. The collapse wasn't a malfunction, it was the end point of its own success.